Welcome everyone. I'm S. Prakash of CSC Department, Jansen's Institute of Technology, and we are going to see a case study report about the topic justify the role of ionosphere for communication. Getting into the case study, role of ionosphere in communication. Introduction. Ionosphere extending from 60 km to about 1000 km altitude plays a major role in aiding long distance HF high frequency 3 to 30 MHz communications, as well as in the deteriorating performance of satellite radio systems in the very high frequency 30 to 300 MHz, ultra high frequency 300 to 3000 MHz, and even higher frequency bands. Interaction of radio waves with ionosphere. An ionized region can affect the transmission of radio waves in at least two ways. Firstly, under suitable conditions, charged particles can remove energy from an electromagnetic wave and thus attenuate the signal. In the limiting case, the energy of the wave can be absorbed. Second, a wave traveling from one place to another in which the electron density is different will undergo a change in its direction of propagation due to the effect of free electrons on the velocity of a radio wave. Absorption, absorption of radio wave energy passing through the ionosphere. When a radio wave enters the ionosphere and encounters a significant concentration of free electrons, some energy of the radio wave is transferred to the electrons, which are thus set into oscillation at the same frequency as that of radio waves. The electron can lose some of the energy because of collision with neutral particles in the upper atmosphere, and it results in attenuation of radio waves when passing through the ionosphere. But if there are no such collision, the oscillating electrons will radiate electromagnetic waves at the same frequency and restore the original radio wave without loss. Appreciable attenuation of radio signal can occur in the D region, where collision of electrons with neutral particles is more due to the higher density of neutral molecules as compared to upper regions of the ionosphere like E and F regions. In addition, collision frequency of electrons with neutral particles is inversely proportional to the square of the frequency of the radio waves, and hence attenuation is greater. The lower the frequency, the lower the wavelength. As a general rule, therefore, radio waves suffer little loss of energy or signal strength in passing through the higher levels of the ionosphere, and most of the attenuation occurs at the lower part of the lower altitudes, that is in the D region of the ionosphere. Ionospheric effects on satellite communications. The, the ionosphere is a useful tool for long distance radio in the HF band. A completely opposite situation arises in connection with the communication from a satellite or a space probe of Earth, where waves of high frequency, very high frequency, that is above the critical value of the F2 region, are used to avoid their reflection back to space. For satellites and space-based systems, the ionosphere acts as a deteriorating medium and affects the performance of the system. There are a myriad of radio propagation effects depending upon the nature of the media through which rays must propagate between Earth and space. These are refraction, absorption, polarization, propagation, time delay. Doppler frequency shift error results from both a time delay due to the increase in the path length and to a reduction in the radio wave signal velocity. In homogeneities, the refractivity due to all the presence of ionosphere irregularities cause fluctuation in signal power and phase of a radio wave propagating through ionospheric media, and the phenomenon is known as scintillation. Ionospheric scintillation causes both enhancement and fading above the medium level as the radio signal transits the disturbed ionospheric region, with the increasing demands placed upon space-based systems in the term of accuracy and data transmission rates. Scintillation is probably the single most important deleterious factor in utilizing the Earth's space propagation path. Ionospheric scintillation disturbs satellite communication, globe positioning, navigation system, radar system performance, and also astronomical observation, all resulting in a serious degradation of data quality. Two areas of the globe particularly troubled in scintillation are subauroral to polar latitudes and the belt surrounding the geomagnetic equator. Hence, the degradation of Earth-space communication link is most severe for propagation paths which transit the auroral and equilateral ionosphere, and the effect is more intense in the latter. Thank you everyone for listening my case study. Thank you.